When you're writing programs that involve the analysis of large data sets, you'll commonly model your problem using a column-oriented data structure, meaning you've got a collection of columns and each column is a list of the values in it. Let's take a look at this in terms of a simple example where we've got, say, the upcoming weather forecast data for the next 10 days. And we could think of there being 3 columns in this table: the high temperature column, the low temperature column, and the expected precipitation. We could model this in Python using a dictionary, where our dictionary has keys whose type are string and whose values are a list of floating points. And I've taken some liberties here in this graphical representation to try and make it feel a little bit more like a data table. Even though this isn't how you would type this in directly into Python as a literal, I'm using the literal syntax to try and help you relate. Well, we think of our dictionary as the keys being the column headings for a given column, and then the values are the list of values for that particular column, right? And so the list of floats are, rain, today's expectation is 30% chance, tomorrow's 20% chance, the next day 40% chance. And one of the reasons why we store our data in a column-oriented format is because it makes it easier to perform analysis on a given column. Typically, we want to ask questions like, what is the average chance of rain over the next 10 days? Or what is the maximum high temperature? And those types of questions are very straightforward to address programmatically when you're working with a column of data at a time. A common problem, though, that we want to be able to express and have a solution for going about in our code is filtering our data set down. What do we do when we only care about a subset of our data? For example, what is the average temperature, the average high temperature of days where it's unlikely to rain, where the days that it's unlikely to rain are those where the percentage is less than 0.3? Well, here we've got our percentage column, and we know that not every day in this data set satisfies that criteria. So we wouldn't want to consider the first day because 0.3 is equal to 30%. We're asking for only the days that are less than 30%. But we would want to keep, the second value. We wouldn't keep the third, the fourth, and the fifth. We would, because that's less than 30%, right? So of this larger data set, there's only 2 in this example that apply to the criteria that we're trying to consider. Well, a challenge when working with column-oriented data is, okay, we know what values we would want to keep in this column, but how do we get, if we're looking for the average high temperature, how do we make sure that we get those same 2 values so that we can average them together out of this other column? And how do we, make this connection between these 2 columns? Well, in this video, we're going to take a look at a common strategy, which is called, selecting by a list of booleans, or masking, in order to carry this out. But let's jump into code so that you can follow along. I've got an IPython notebook here where we've got some data that's already been set up and a little bit of analysis on where we're going with this. So that same data set with 5 extra days added to it is shown in this data here. For those of you following along with the course who have this workspace set up, you can pull this information and have it show up in ls19_filter start.ipython notebook. Otherwise, in the description of this video, I'll leave a link to the source of this that you can download and follow along with directly. In this first cell, what we're seeing is just that data that was presented on the previous slide, where we've got our columns. But notice that this is a little bit harder to parse, right? This almost feels like it's like the table's been flipped on its side. This is our column title, and these are the values for each row. The more visual representation of it, to think of it in terms of the actual data table, it would look something like this, right? So the first day's data are all of the indices 0 of each of these value lists, right? So the first thing we'd like to do is, again, we're trying to find the average high temperature of days where it's unlikely to rain. How can we go about this type of analysis? Well, I'm going to set up a new cell and first try and do a little bit of pre-processing, find the days where it is unlikely to rain. So I'm going to make a quick note here, and the note is going to say, produce a mask based on criteria. Right? So this less than criteria is what we're looking for. Right? So let's define a function named less than, and actually we need to do this in our next cell. So I'm going to use the Shift Enter shortcut to move to the next cell and go ahead and evaluate the one I was previously in. And this sets up a new cell, and let's go ahead and set up a function named less than. And this less than function is going to take the column that we're looking at. So let's name this column, which is a list of floating point values, and then some threshold or some value that we're going to pass in that is, a floating point value. And what this is going to produce, kind of bizarrely, but will make sense in just a moment, is a list of booleans. Okay? So the idea is we're going to give a list of floating point values and some number to test them all against. And we're going to produce a list of booleans where it's just going to be true or false. Was the number at this given index less than the number we gave for this parameter? So let's go ahead and give an intuitive example of this with our slides. And I've got these values set up here where these are the percentages on a given day. And let's imagine that we're processing, less than 0.3. What we expect to get back is we would test, is this less than 0.3? And that is false, right? That is equal to 0.3. Is this less than 0.3? That would be true. Is this less than 0.3? That would be false. And false. And true. So notice we're effectively creating a mapping between two lists. We're saying, for each item in some input list, we're going to test each one by one, whether or not it meets the criteria of being less than whatever our parameter is, and we'll try it with 0.3. And we're going to produce a second list of Boolean values containing whether or not that given value at the same index of the column satisfied this criteria. So let's try implementing this. So our result is going to be a list of Booleans, and it will initially be empty. Right? One of the things that I like to do when setting up a function like this is just go ahead and set up, here's the variable that I'm going to be producing my result in and working and manipulating and mutating in order to achieve our goal here. And ultimately, we know that we're going to return this result. I like to do those two things so that we know that we've got a working function definition. This will return a list of Booleans, but this is not quite a correct function yet. It's just the skeleton of a function. Okay? Now, one of the things that we can do, and is kind of fun with Jupyter Notebooks, is I'm going to go ahead and try calling this function and just giving us a sense of whether or not it's working. So we can set up a call that's an example call, and maybe I'll make a note of that. Example testing call. So less than, and what is our column? Well, our column, we've got our column data up at the top, and we're looking for the rain column, right? So column data rain, and what are we testing? Whether each item is less than 0.3 is the number we've been using so far. So if I try evaluating this, we see that this call to the less than function that we just started defining returns an empty list, and that's what we expect. But let's go finish up this implementation. So what are we going to do? We're going to loop through each item in our column, right? And then we're going to test if that item is less than the threshold parameter, right? So that threshold is the parameter. We're saying that's going to be 0.3 in this example. Then what are we going to do? We're going to assign to result.append true. Else result.append false. Right? And we're going to try implementing this in a slightly different way in just a moment, but this is a first approximation, just sort of doing this in the most straightforward way we can imagine. If item is less than threshold, we append true, otherwise we append false. And notice we get false, true, false, false, true, true, false, false, true, true. And if we were to look at our inputs, we could see, okay, there's the one true, there's the second, there's the third, and then we end with 2 at the very end. So it looks like this works. A common pattern that is what we call an anti-pattern, meaning when you see yourself writing code in this way, there's a better way to do it. A common pattern when you're making some test, and in this case, appending true or false based on whether or not this was true or false, recognize that this Boolean expression has to evaluate to either true or false. And when it does, we're using true, and when it doesn't, we're using false. So we can actually, and I'm going to select these lines and press the Control/ shortcut in VS Code, or you can just add hashtags in front of each of these. And let's rewrite this to something that's a little bit more idiomatic, meaning more commonly used. Result.append item less than threshold. Okay. And I'm going to add another comment here. The above line is the same as the following. Right? So for each item in this column, we're going to evaluate this expression. Is that item less than our threshold? And then that's either going to be true or false. And when it's true, we're going to append it. And when it's false, we're going to append it just the same. So notice that we were able to avoid having this conditional inside of our loop where we were appending true or false based on this expression being true or false. And we can just do this directly. Right? Great. So now if we try rerunning this, we can see, sure enough, this achieves the exact same thing. And now we have this function that given some column, we can test whether or not all of its values are less than some parameter we give, and produce this list of Booleans, which we're thinking of as a mask. And you'll see why I call this a mask in just a moment. One thing I meant to mention before is we made use of this here, but I want to actually go back and mention this and leave an example in this file. We can access the values of our columns by accessing the data structure at the top level. This is our dictionary, and then the column name, right? So for example, and maybe I'll go back and just after this, add another demo cell here that is, we can print call data rain, right? And if I evaluate this cell, we see that it gives us back just the values of that rain column. Right? So this is how we're accessing that column's values. Similarly, if we wanted to access the high temperatures, we could print its values. And so we can ask the data table for the column values given a key. Right? Great. So now that we've got this, the ability to test whether or not every value in some column is less than some threshold, we can establish a list, what we're thinking of as our mask. And so I'm going to assign this resulting value, the result of calling less than, given these parameters. I'm going to assign this to a variable named nice days mask, or no rain mask. And it's a list of Booleans, and we're assigning that call. And then I'm going to go ahead and print this out, just to remind us what's going on. Okay. So these are the values of our mask. Now what are we going to do? Well, what we'd like to do is take this mask, and let me go back to this example over here. And use it to decide which values of some other column we're going to process. Right? So let me pause the video here for just a moment and write these values in, and I'll come right back. All right, so I've got my high column values now added to this slide here. And I want to talk through this algorithm we're going to apply next, which I think is easily thought of as masking some list of values with a list of Booleans. And what we're doing here is we're going to filter down to only those values in some other list, where in our mask, we have a value of true at the corresponding index. So if we add indices to these two lists, so this is indice 1, 2, 3, 0, 1, 2, 3, and 4. And now we think, okay, our algorithm is we look at the first item of our mask and we see that it's false. So we're going to skip over this high item that's corresponding to it. We look at the next index, index 1 of our mask, and that's true, right? So that means we want to keep the value 84. We look at the next item, that's false, we skip over it. The next item is false, we skip over it. The next item is true, we want to keep 65. And the result of the function that we're writing, which is going to filter down our data, is going to produce a new list. We can think of this as the masked list of high temperatures. It's only going to have 84 in it and 65 in it. Right? And think about this process, what we just applied. And we started with our rain column, and we said, okay, well, let's produce a mask where the values, each item in our mask will be true if the item in rain is less than 0.3. And so that's our mask here. And now we're going to say, okay, well, now what we're going to turn our eyes toward and start to analyze is this high column. And we want to keep only the values of the high column that satisfy this mask. And the reason for this is so that we can narrow in on related columns values. So we're starting with some criteria on the rain column, and then we're saying, okay, well, we're trying to do this analysis on the high column. Again, what we're trying to do is of days where the likelihood of rain is less than 30%, find the average high temperature. Once we've narrowed down just the list of temperatures that are the days that it's unlikely to rain, it's very easy for us to go find the mean or the average of these values. So let's try writing a function that I'm going to name masked here. Right? So and let's, before we do this, let's add a note. So masked function takes in a column and a list of masks, Boolean values. And these two things do need to be the same length. And typically when we're thinking in terms of a data table, we know that each of our columns has the same number of entries in it. And that will be true here, right? We looped through each item in one column and we appended the result of this condition based on the number of items in that column. So we'll have the same number of items in, say, the high temperature column. Takes in a column and list of masks, returns only the values in the input column where the corresponding mask value is true. Okay. So let's try writing this function, def, and then we'll call this maxed. You can think of this, you might see this referred to in other contexts as Boolean selection or Boolean indexing. I like thinking of this as masked because when you use masking tape, when you're painting a room, you put some tape down and when you paint around it, you're deciding, well, what actually gets painted versus not. And so here we're trying to mask out any of the values that correspond to false, right? And otherwise we're trying to keep the values that are true. So our mask is going to have a column that's a list of floats, and our mask is our list of bools, right? And we're going to return a list of floats. So we need to set up our result variable. And so our result is going to be a list of floats and initially empty. And as a matter of good practice, I'm going to go ahead and return the result. So I remember to do that. And so I can go ahead and set up a test call. My test call is going to be masked. And what is the column that we're trying to mask? Well, that's our calls data. Sorry, data calls is what we named that. No, call data. Sorry, call data is what we named our data table. And then we're looking at the high temperature column. And the mask that we're going to use is the one that we set up just above. So this is the no rain mask. Right? So no rain mask. Okay. And if we evaluate this, it's the empty list. And well, that's expected because we haven't actually implemented this function. So how do we think about implementing this function? What's it going to do? Well, our goal is to loop through each index of our mask and test, is this value true? And if it is, then we will append the value at the corresponding index in our high column, or in whatever column we give it. We can test the next item. Is it true? And if it were, if we get to this one and it's false, we're not going to include that item. So it's only for trues that we're going to actually include those values in the resulting list of values, right? So let's try adding this logic here. Because we're working with two lists, and we have to keep track of their indices relative to one another, we need to work index by index. So I'm going to use a for loop where the I value is in the range of the length of our mask. Right? Now, if we were writing defensive code and we were very concerned with potentials for errors here, we should have checked to be sure that the length of our column was equal to the length of our mask, because this algorithm won't make any sense if they're different, and that would be an unexpected use of this function. We're going to trust for the simple demonstration that they are the same. And so we're going to loop through for each index in the range where we start from 0 and we go up to the length of the mask minus 1. We're going to test and see if the mask at index I, and we could test if it's equal to true. But remember, because this is a list of booleans, that value already is either true or false. It is a boolean. So this is a little bit redundant. We don't need to say, is this equal to true? Because either it is true or it isn't. And so if it is true, if mask at index I is true, then what we're going to do is result.append. And what are we appending? Well, the column value at that same index, right? So if the mask is true, that means we're going to include it. We're going to append that item at that same index of our column, all right? So now let's try running this, and we see 84, 65, 67, 55, 61. Just to try and make this line up, I'm going to go ahead and print out column data of, let's do the rain, that's our percentages, and then print no rain mask, and print column data high above this. And this is what we walked through effectively on that previous slide, right? So what we see here is 0.3 is less than 0.3, that's false. So 77 is not included in our result. So this is our result. This is high. This is our mask. And this is rain, right? Now 0.2, that's true with our mask. So 84 is going to be included in that result. 0.4 is not, that's false. So 78 isn't. 0.8 is false. So 79 isn't. 0.0 is less than 3, so that's true. So 65 is going to be added to our result. 0.2 isn't, or sorry, no, 0.2 is. So 0.2 is true. 67 should also be in our resulting list. Sure enough, it is. 0.4 is not less than 0.3. 0.5 is not, so false and false. 74 and 61. 0.1 is, so it's true. And that means 55 is in our list. And 0.1 is also true. So 61 in our high is in our resulting list. So what we've just done is we've taken a look at our rain and tested whether each percentage likelihood of rain on a given day is less than 0.3, produced a mask, and then we're filtering our high column based on those results and keeping effectively only the values where that are for the days where the likelihood of rain was less than 0.3. All right. So I'm going to go ahead and remove these prints. This is just for demonstration purposes. And let's actually store this result in our highs of no rain days variable. And this is a list of floats if we wanted to be specific about that. Right? And if we wanted to, we could print out highs of no rain days. All right. And now we want to find the mean of this? Well, what is the average high temperature? That was our goal. So let's go ahead and add one more markdown, compute the mean. Right. So let's just make a simple little mean function, a mean little function that takes in a list of floats. That's our column, and returns a single floating point value. And here we're going to use the built-in sum and divide that sum by the length of our column, right? And if we wanted to, we could try, well, what is the mean of highs of no rain days, right? And it's 66.4, right? And so this is kind of cool. We now have 3 functions that we can use. The first one is to test whether or not values are less than some other value, and that will produce our mask. And then we can take a mask and filter down some other column based on that mask. And last, we've got a simple little function for computing the mean. So now we can actually show you why it's nice to organize our data in terms of columns and how we can get some reuse out of these ideas. So just to bring this demo home, get with these helper functions, we can perform mini analyses, right? So we just have these 3 functions, and let's try asking ourselves, well, let me think of something off the top of my head. What is let's go look at our data set real quick. What is the average likelihood of precipitation for days where the low is less than 50 degrees? Right? So notice that's a very different question than what we just asked, but these 3 functions can help us analyze it, right? So the threshold here that we're looking for are days that are less than 50 degrees. So what we're going to say is, okay, cold days mask is a list of booleans, and that's going to be, let me get this column data. So we're going to take the less than of column data, and we're looking for days less than 50, all right? So if we were to print cold days mask, oops. So less than, I forgot to index the column here. So notice this is actually a great demonstration of when you accidentally forget to index a given column. Notice what we expected here with this less than function is a single column, but I gave it the whole table. So I needed to say the low temperature if that day is less than 50, right? So here we get back our mask. So this day was less than 50, this day is less than 50, so on and so forth, right? Now we can say, let's find, well, what are the actual % chances of rain on the days where it's cold? Well, this is where we can use that masked function. So I might say rain on cold days is a list of floats, and we're going to use the masked function. And first we give it the call data of rain, and then our mask is our cold days mask. And if we were to print rain on cold days, we see, okay, here is the likelihood of rain on these days. And if we wanted to find the mean of that, we have a function that we defined previously, and we see like on the days where it's going to be cold, there's a 30% chance of rain on average based on this data. And notice that we just performed, in a sense, very similar analysis, right? Check one column whether or not its values are less than some value, then filter down some other column where those were true, and then find the average of that. And this process is very common, but notice that we're not tied to specific columns here. We can mix and match without having to go and rewrite these functions. And so it's, we probably want some more functions like less than, like maybe we want a greater than function that will produce a mask of values that are greater than some threshold, or an equal to, or you can imagine many other types of tests that we might want to perform on individual items in a given column. But all of those functions could ultimately produce masks, right? Which are just lists of booleans. And then we can take those masks and use the same masked function and actually filter down some other column based on that criteria. And so we're able to find relationships or narrow down our columns based on the values of other columns in a way that lets us filter our data and perform the analysis we'd like without having to reinvent these functions every time. This style of filtering based on some criteria applied to a column and then effectively translating or transforming another column based on that criteria to narrow in on some results is very common when you're working with many popular data science libraries and programs. We'll look at the Pandas library later in this course. It's a very popular data analysis library that has all of these functionalities built in. But understanding how it works under the hood and this process of testing one column, producing what we think of as a mask, and then filtering down some other column or even an entire table based on that is a very common thing that you'll do in those frameworks that once you've done it yourself and sort of implemented these ideas at a very low level in a simplistic example as we've seen here, hopefully will make much more sense when you get to those libraries that are popular in industry and in research labs. So great work on this video of filtering down data based on Boolean mask.